demo section of the lecture. Instead of running Metasploitable, just to demonstrate that this is a vulnerability with the ARP protocol itself, or just a limitation of the ARP protocol, I'm running my preferred pen testing machine here. And so here, the OS that I'm using, it's Linux, but it's a distribution of Linux called Parrot OS. And I like it a lot. I think it's a great pen testing distro. And it's the most up-to-date kernel, up-to-date in every way. And the reason I like it is because it has these really great features. It has an awesome anonymous feature and awesome cryptographic tools for encrypting and decrypting information. So the anonymous surf feature will route all your traffic through Tor. So you could start it up and you could say, okay, go ahead and route all my traffic through Tor. And that's just one of the really nice things about this distribution. So what we're going to do here is we're going to go ahead and execute an ARP spoofing attack. And with this ARP spoofing attack, I'll intercept traffic that's passing through this machine to the router in our virtual network. And so I'll go ahead here, and the IP address for this machine is 1.11.0. And I know that because I've just done a net discover beforehand. And so here, we'll go ahead and spoof in this direction. And we'll also spoof the router and pretend to be 10.11 as well. So here we're starting to do our queries. And so let's go ahead and pull up a terminal here and let's inspect the ARP table here. And so you notice 1.11.5, this is my Kali machine, and its MAC address is 081C. And you'll notice that it's also overridden. Now in the entry here, 1.1 has been overridden. So the MAC address here is 801C. And so even on the most up-to-date version of Linux, see if I do a uname-r, you'll see that this is running Parrot 570.2, and that's the most up-to-date version of Parrot OS here. So even on the most up-to-date version of some Linux system, even a hardened one like this, it's still vulnerable to these kind of attacks. So let's go ahead and generate some web traffic. But before we do that, let's open up Wireshark. So click on Wireshark from the search bar, and then I'll just type in my password there. And then you can see there are a bunch of interfaces. So ETH0 stands for Ethernet 0, loopback, that's the virtual internal interface. And then I have some things on my system like Bluetooth radio, but we're not going to be using any of those. So let's go ahead and just click on the Ethernet interface because that's the one we want to monitor. And you'll notice there's some ARP traffic, some ICMB traffic, and so on. And what we want to do is ICMB is network level traffic, router to router communication. Things like traceroute use it. And so we want to just limit it to ARP. So here you can see all of these ARP queries that we're generating, and as it goes on, it's generating more. And if we click on it, you notice that Wireshark's actually detected that something fishy is going on. It says that in one frame, 9.2.11 is at 1C, which is the Kali machine, but it's also used by our pfSense router at EA66. And so same thing here. It's also noticing that something's fishy is going on with 1.1. And it says, oh, it was previously at 4B75, and it looks like 801C is pretending to be it. And if we look here by running either an ipconfig or IPA, IP is replacing ifconfig. So you'll have to get used to this protocol or this command structure instead of ifconfig or ipconfig. And so here, if you look, you'll see that this is 4B75, which is here. So Wireshark's actually detecting that something fishy is going on here because it's looking and analyzing that traffic. So let's go ahead and open up Firefox here. And we'll go ahead and just look at the DNS traffic. And so you'll notice that there's a bunch of DNS traffic that's getting generated, some by Firefox here and so on. And we were able to capture those DNS packets that went through here. There was this detectportal.firefox.com. There was some startparrot.sh, and it's not using DNSSEC. So we can actually see the sites that it's visiting. And so if we went and visited something like google.com, whoops, you'll see here, we get all those things for Google. So there's some ad stuff and google.com is here. And that's because DNS is secure here. I'm not using DNS over HTTP, so I can see all the traffic. And the same thing is true for your ISP. Your ISP can see all of the sites you visit because the home router that you have normally uses the ISP's DNS server to view that traffic. And the same thing that's true here at UVA. So if you're on campus, we have DNS servers on campus that respond to your DNS requests. And so we can actually see that traffic as well. One of the things to note, so let's go ahead and just limit for IP to 10.10. So you'll see that there's some keep alive packets in here, but let's go ahead and look at one of these streams. Maybe we'll generate something from yahoo.com. So we get a new stream here. So let's go ahead and do www.yahoo.com. And so here we're getting some TCP packets. So let's go up here somewhere. Now let's stop it here just so that we don't have a lot to deal with. And you'll notice this over HTTPS. So even though we're intercepting these packets, we can actually read these Yahoo packets. So if we went and did follow TCP stream, you'll notice that they're encrypted, which is great. Yeah, you can intercept them, but you can't really read them. But not all of these. So Yahoo's actually using a good version, good type of encryption, TLS 1.3, which is good. But some of these encryption mechanisms, some of these versions of TLS are actually not secure, like TLS 1.1, TLS 1.2. And even though the traffic is encrypted, you might be able to crack it depending on the encryption type that's used. And so we'll talk a little bit more about that when we get to the section on encryption. So let's go ahead and restart this, and we won't save our previous results, and we'll clear our filter here for that particular stream. And then let's go to a site that doesn't actually use HTTP. So let's just go to one of ours, so cs.virginia.edu, and then we'll just visit my site here. And so that we can get so that we can just limit this, let's just do DNS here. And I didn't get a DNS query for this. Why was that? Maybe because I visited it before. So let's do a lookup here. Let's refresh this, continue without saving, and do another request. Something strange is happening there. Maybe this page is cached because it's so simple and I've visited it before. Let's visit Charles's page. Oh, what is happening there? Let's go ahead and restart Wireshark. Yeah, this is one of the disadvantages of doing a live demo. Okay, we are capturing traffic. And let's go visit me. So HTTP unencrypted, cs.virginia.edu, and my site. Okay, that's good. So let's limit this to just DNS. No DNS packets. Let's limit it just to packets from, yeah. And then let's check to see, actually, let's do a contains. So let's see, DNS contains Virginia. No lookups for me. Okay, let's see if we have any TCP packets that contain my name. TCP contains Daniel. Ah, here we go. Boom. So here's the exchange. And let's go ahead and see if we can follow this stream. Ah, and there we go. There's the personal site. So here's all of my content for that personal site. And let's go ahead and do Charles's site as well. And so let's see here. So this is an HTTP request. So let's go ahead and drop that down from HTTPS to HTTP. Okay, and then let's do TCP contains, let's pick something on the site here, transistors. Let's see, transistors. Great, and let's follow this stream. See if we also have recovered that page. Yep, great. So that's that page there. So for pages that aren't encrypted, you'll notice that there's this block or lock towards the top and it says not secure. And that's because we can do things like this. We can actually go ahead and read the traffic that you send here. And so this is not, it's not the best thing in the world. That's just a quick kind of overview of Wireshark, some Wireshark filters, and you could go ahead and filter stuff on your own and practice by following the write-up there. Okay, so let's go ahead and clean up those ARP tables by killing this here. And we'll close this. And we can actually look at all those ARP queries here as they get cleaned up. That's restoring them. So this is actually a bad one. Oh, here we go. Okay, so now that's restored. Go ahead and play with Wireshark. Oh, I did want to point one thing out before we close. So I'll stop this. So one of the things that you'll notice here that we talked about was this idea of encapsulation. So here's this whole frame. So this is the whole frame containing the ARP query. And you'll see that it goes through a bunch of layers. Actually, let's look at a TCP packet from one of these streams. So let's look at here, like this one. So you'll notice that there's a frame, and a frame contains everything in the packet. And then there are different layers here. So inside of that frame, there's the Ethernet frame. And inside of the Ethernet frame, there's the IP protocol. And inside of the IP protocol, there's the TCP protocol. And inside of that, TCP protocol. And then inside of that, there's actually the TLS protocol. This is for encrypted communication. And let's pick something that actually isn't encrypted so that we can see here. This makes it really easy to see. So TCP contains Daniel. So here, our top frame contains everything. So if I hover over the frame, that's everything. And then inside of that, there's the Ethernet header. And then inside of that, or next to that, it's actually wrapped inside. Here is the Internet Protocol header, and then the TCP header. And you might see in Wireshark, it might not be in bits here. It might be in hex like this. And so you can change it in between. So this is all the contents of that TCP packet. And if you open this up, you'll see all of the header information. So you'll see the protocol, you'll see things like checksums and so on. And so same thing for DNS. And here you can see the source and destination MAC address for that Ethernet frame here. So, Wireshark will parse the packet for you. It'll parse all those ones and zeros. So just go back to the bits here. It'll parse all these ones and zeros in the packet. And it will tell you what each field means, and you can go ahead and explore it in that way. And so learning these queries and learning how to read these fields is going to be really useful for things like debugging and forensics and debugging some of the network applications that you'll write. So just go ahead and get some practice there. All right. So best of luck with the homework. And
great. So if you're enjoying these lectures, feel free to check out the full lecture series on Udemy. The link for that full lecture series is in the description below. Thanks.